at differences between modern science and Greek science and how that is relevant for logic. And we've just heard some various differences between differences in emphasis or difference in the significance given to various factors when comparing Greek science and modern science. So Dewey has talked about the changing importance of quality and quantity, heterogeneity and homogeneity, the changing significance of relations. And now he's going to mention one last thing, focusing on change. Let's get into it. So he says that the next difference to be mentioned is found in the central place occupied by ens and teleology in Aristotelian logic. In converting that logic into a merely formal logic, the teleological factor has disappeared. So teleology is about kind of the natural endpoints of things, the end states of things. Classic example being that an object thrown in the air that tends to go towards the center of the earth. It has a natural kind of resting state, which would be, I guess, in the middle of the earth, but it's blocked, of course, by the ground. And you might think of species, natural living objects as having natural end states too. So the acorn has the goal, let us say, of turning into an oak tree. Things like that, right? Talking about teleology. So he says that teleology was so central in classic logic that it may be affirmed that with its disappearance, the reason for Aristotelian logic has also vanished. So teleology has a much more tenuous place in modern scientific thinking. We don't really feel comfortable saying that the acorn has a purpose or the falling rock has a purpose. There are certain sorts of systems that when they're put in the right kind of environment tend to do certain things, act in certain ways, but we don't really think about them. I mean, there's disagreement about this, but it seems to be the tendency of science to reduce teleology, look less at purposes, and to see things more in interconnection with the surrounding environment and what happens when you get systems into relation with each other. So where were we? Yeah, so the reason for Aristotelian logic has also vanished, which is based on this idea of eternal species with their inherent teleologies, or teloi, I guess would be the plural, their ends. Nothing, Dewey says, nothing is left but an empty shell, forms without subject matter. So we have the form, we've retained a lot of the Aristotelian forms of logic, but we don't have the same worldview grounded in eternal species and kind of natural ends of things, natural teleology. In concluding this phase of the discussion, I shall refer to the foundation of all the differences that have been mentioned, the reversed attitude of science toward change. So we saw several pages ago, I believe it was around page 89 or so, where Dewey said a lot already about the idea of change and the ancient Greek conception of change, where change is things that change kind of lack real being. It's change is kind of the accidental. It's the the contingent, the non-necessary, and so true, real knowledge, rational knowledge is of things that don't change, kind of ignores change. Whereas modern science is all about change. It's, takes change as a basic premise. Things change. That's kind of a basic premise of the universe for modern science. So you've got this reversed attitude toward change. Going on. So completion of the cycle of scientific reversal may be conveniently dated from the appearance of Darwin's Origin of Species. So basically, there had been this changing view of change, shall we say, going on. And with Darwin's Origin of Species, we can see a clear break, maybe with the earlier view. Why? Well, so Dewey says, the very title of the book expresses a revolution in science. Think about that for a moment. The Origin of Species. Why does that express a revolution in science? And Dewey continues, for the conception of biological species had been a conspicuous manifestation of the assumption of complete immutability. Right? So species, this concept of species, those were the things that were immutable. Right? Species were eternal. The objects that kind of manifested those species came and went, but the species themselves were eternal. And here you have Darwin saying that, no, species have an origin. The species also come and go. It's not just that individuals come and go, but species themselves have a history. They come, they originate, they change, sometimes they disappear. This conception had been banished before Darwin from every scientific subject save botany and zoology, but the latter had remained the bulwark of the old logic in scientific subject matter. And famously, it's been very difficult to get rid of teleology in biology, and for a long time as well, people assumed that the various species were just kind of eternal. They were created kind of at once by a creator deity, and they seemed to be kind of just inevitable parts of the world, that you had this maybe great chain of, it was conceived in different ways, but this great chain of being, we've talked about this idea as well, of various kinds of species with human beings at the top. And there was good cultural reasons why we did not want to get rid of that idea of maybe that the place of human beings was a bit more uncertain than maybe we thought, and we didn't really like that. So it was difficult to get rid of this more fixed conception of species in the life sciences and biology, because now we're starting to talk about human beings and things that are very close to us and to our concerns. All right. Next paragraph, I believe. So, Dewey writes, when eternal essences and species are banished from scientific subject matter, the forms that are appropriate to them have nothing left to which they apply. Of necessity, they are merely formal. They remain in historic fact as monuments of a culture and science that have disappeared, while in logic, they remain as barren formalities to be formally manipulated. So again, this critique of the forms of formal logic. An illustration is coming. So a striking illustration is afforded in the change that has taken place in the status of mathematics. In Greek logical theory, mathematics was an existential science. So mathematics as an existential science, as dealing with with being, rather than potentiality or something like that. So an existential science. The discovery that the relation of the hypotenuse of a right-angled triangle, whose other sides have the value of 1, is not numerically expressible, showed that magnitude and number as such are completely irrational or illogical. And now we're getting into a slightly complicated area. I don't want to discuss too much because I'm not smart enough about math. But basically, you may remember your right how to deal with right triangles, a squared plus b squared equals c squared. So if a and b are 1, right, you end up with, 2. And then you would need to do the square root of that, which is an irrational number. And so that's a problem, I guess. So anyway, we'll kind of, again, won't take too much time with that, exploring that idea. If you know more about mathematics, you can, or the history, I guess the history of mathematics, not so much mathematics itself, but its history, it can be something to ponder. He says, the fact that a ratio remained constant no matter what the magnitude of the size and area of the triangle, together with the paradoxes of Zeno, helped to produce the doctrine of the accidental nature of quantity. And you may know Zeno's famous paradoxes. I don't want to get into those too much. But this kind of helped bring about this idea that, or reinforce this idea that quantity was accidental, right? If you remember the Greek conception that we discussed in 1 or 2 videos ago, where quality is much more central than quantity. Quality is of the essence of things, whereas quantity is accidental. And so mathematics is dealing with that kind of existential, accidental stuff rather than the essential and the eternal. It led to the notion that true number, as distinct from quantity, is geometrical in essence. For geometry was based on the conception of limiting measures, which determined the forms of objects in the sense of their configurations. The movement represented at first in Cartesian algebraic geometry that affected determination of all figures by formulae of generalized numerical coordinates was more than a new instrument of scientific analysis and record. So now we're moving into Descartes. Descartes is 16th century, right? Or 16th, 17th century. So now we've moved ahead in history past the ancient Greeks to something kind of new, which Dewey says marked the beginning of the logical movement by which all mathematical propositions became formulae for dealing with possible objects, not descriptions of their existing properties, so that they are logically non-existential in their content, save when taken to prescribe operations of experimental observation. And this, again, gets into controversial territory, shall we say. And this is kind of Dewey's particular view of the history of mathematics and how mathematics is used in science, and we get into things like operationalism, which was an early 20th century view of kind of scientific practice and scientific meaning, which I don't think I want to get too much into right now. But the idea here is that mathematics is about kind of potential operations that can be performed to lead to experimental observation. So that's when he talking about prescribing operations of experimental observation, and that's what mathematics is useful, not for describing how things actually are, kind of prescribing what we should do in order to have certain observations rather than describing what actually exists. And this is a subtle difference, a difficult difference, but it marks another difference between kind of an older conception of science and a newer conception of science. All right, let me check where I am in... Okay, so a couple more paragraphs here. So continuing on to the next page. The entire matter may be summed up by reference to the different conceptions of nature that are involved respectively in ancient and modern science. In Greek science, nature was a qualitative, a bounded and closed whole. So a bounded whole, right? With boundaries, with limits, a whole kind of a thing. To know any special subject was to know it as a whole in its proper place in the comprehensively inclusive whole, nature. So you have specialized knowledge of particular topics, which are themselves wholes within this more comprehensive whole that we label as nature. It is not true that ancient science attempted to deduce knowledge of the included wholes from the conception of the final and complete whole. So you would not try to figure out the properties of kind of the sub-wholes from a conception of the final complete whole. The notion that Greek science was deductive in this sense is a profound misapprehension. So we shouldn't understand Greek science in this way. In the Greek scheme, knowledge consisted in placing each relative species or whole, defined and identified by its own essence, in relation to other species within nature as the final whole. So you wanted to see species in relation to each other. The necessity of referring all special kinds and modes of knowledge to nature as a closed whole explains why, in the classic conception, there could be no sharp distinction between science and philosophy. So philosophy is, well, as Dewey is kind of using philosophy as a shorthand here for the speculative conception of a whole that's beyond experience. So there is no sharp conception here between science and philosophy when you are putting species in relation to each other as kind of enclosed by a comprehensive whole. The subject matter of modern natural science consists of changes formulated in correspondence with one another. So rather than fixed species in relation to each other and to a comprehensive whole, you have changes in relation to each other, changes formulated in correspondence with one another. This fact not only gives a radically different status to change, but it radically affects the conception of nature. So what is nature then if what you are primarily dealing with are changes correlated with each other? The formulation of correlated correspondences becomes more and more comprehensive more and more comprehensive in scope. So we're dealing with larger and larger kinds of changes, more and more maybe inclusive changes at many different levels, right? You've got kind of these microscopic changes going on, mesoscopic, macroscopic, whatever kind of levels you want to posit, or maybe more local and more universal kinds of changes going on. So we can have more and more kind of comprehensive changes correlated with each other, but no scientist today would dream of setting up an all-inclusive formula for the universe as a whole. So there's no universal formula. You can have formulae for very large, near universal changes, formulae for dealing with changes that seem timeless in a way, thermodynamic changes that seem to be relevant for everywhere and at all time and over really huge distances and temporal scales. But we don't have a formula for the universe as a whole. That job, Dewey says, has been taken over by certain philosophic schools. So there's a certain kind of metaphysics. There's different schools of metaphysical schools that attempt to say what the whole is like. Certain kinds of absolute idealism, certain kinds of materialism have a view of what things as a whole are, the nature of things as a whole. And you might say that this is the kind of the job of metaphysics, but that's different from now what we think of as science, or maybe should think of as science. The change in the conception of nature is expressed in summary form in the idea that the universe is now conceived as open and in process, while classical Greece thought of it as finite, in the sense in which finite means finished, complete, and perfect. The infinite was the indefinite in Greek science, and the indefinite as such could not be known. So that is what escapes our knowledge in Greek science, whereas in modern science, everything in a way is we're forced to know the indefinite. The indefinite is what we deal with because things are in process. Now, again, this is controversial. People have different views of it. At least philosophers have different views of it, and scientists, when they are thinking philosophically, have different views about it. I think Dewey would argue that if you look at the practice of scientists, this is how they practically treat things, as an open process. Things are in process. We have to kind of practically treat things in that sense. Make sure where I am. I think we are finished and we are going to finish up here. This is the end of a section. In fact, it isn't so obvious in the digital version here, but in the printed version, this is the end of a major section. So, probably a couple more videos to finish up this rather difficult chapter, at least for me, as it gets into ancient logic and the ancient conception of nature, which is very interesting, but I have less grounding in the ancient world. But it's important to realize where Dewey is coming from, why he thinks that we need a new kind of logic. Anyway, we'll stop here for now. That's all. Thanks for listening.